My name is Shaun McCullough. I'm actually really excited about this talk because this talk is really based off of the work we are doing in GitHub. It's not exactly word for word exactly what we're doing, but it is a construct of like, this is the plan, this is what we're in the middle of, and we're not done. So it's kind of neat to do a talk about where we're at, and hopefully we'll find some more problems along the way as we keep going. So that's always kind of the fun part of these kind of conversations. Just real quick, so as he said, I am a cloud security architect with GitHub. I work on the team that runs our cloud posture management program. And we spent the last 3 years rebuilding a brand new program, and I'll talk about that in the beginning. Right now, we're working on moving that program from alert-driven to guardrail-driven, which is really the second half, the goal of the conversation today. What works, what doesn't. You'll see I have some favorites of how we do things in the different clouds. I'll talk a little bit about AWS and Azure because those are two clouds I know the best. If you're working at Google, that's awesome. I just don't know Google that much, so I'm not going to pretend up here. I spent 20 years in the National Security Agency in both offensive and defensive cyber operations. One point was the tech director for Blue, Red, and Hunt. So my old career has been on threat-driven security. That's really kind of where I grew up on. All right. And yes, this is a Halloween-themed talk. That's actually one of the reasons I always come here, because I just like doing silly slides. So that's where we're going to be at, silly slides today. When a couple of things about definitions, when we started building our cloud security program a number of years ago, kind of rebuilding it and refiguring out how we want to do it, a couple of things that we wanted to make sure of. We wanted it to be not a series of things that we do, but a program that was repeatable, so that when I'm gone and the team's gone and other people come in, the program continues. I don't know if you ever worked in a place where you work really hard and then someone leaves and it just kind of falls apart because it's not ingrained. So we worked really hard to build a program that is part of the program. It's part of how we do our day-to-day. We already have a program for what we call fundamentals. That is really, we're going to secure things in different ways. And so we call them fundamentals. And so part of fundamentals, we have a set of what we call security findings. I'm giving you some definitions because I'll probably use them throughout the talk, and I want you to know, what is he talking about, findings? Findings are like a control. The word control is used in so many different ways that we just jettisoned the idea of using that word because it was too confusing, and we use a finding. And a security finding is something that is actionable. Like, it is something that is specific on what I'm going to do to fix a problem. You're not going to allow S3 buckets to be accessible from the internet. All right, so how do I do that? In Terraform or command line or whatever it is, I'm going to make a specific change. So that's what we're talking about with security findings. Sometimes if you do stuff like CIS controls, the CIS controls are kind of high level. This is very technical description. We decided that every security finding has to have 4 things. It has to be documented, so we have to write it down in a place that people can read it. It has to be implementable by the teams that we're telling that to go and fix it. It has to be auditable. I have to be able to look in a place and see everybody that has deployed their S3 buckets on the internet, or people who have not. So that's got to be audible. And I have to be able to provide alert to the owner to go and make a change. If I don't have those 4 things, we don't call it a security finding. It's a recommendation, which are nice. I mean, recommendations are fine, but it's not a specific control or finding that we can say, you need to go fix this at a certain time. Okay, so that's our definition of finding, just so you know. We built an alert-based system using these findings where we identified different sets of findings that we're going to specify for different kinds of cloud resources. We identified, of course, there's things that are critical and highs, right? So everybody, we're going to work on those. It's the mediums that are always a questionable thing, like when do we do it? How do we do it? What's the right way of deploying those? And we started building up this alert-based environment. Now, everyone's environment is completely different, right? So if you work at a government or at a bank, then you can only deploy things in a very specific way that's been predefined. For a lot of people, though, you work in a company where you started doing cloud development and then they hired you to come and fix it. I don't know if anybody ever in that position, ever heard of that? Okay. So sometimes companies can be on the complete other end. Hopefully, people are in the middle most of the time. Where there's things out there that are maybe not as secure as they can be. There was an attempt to make them secure, but they're probably not in the best case. One other real problem it's a good thing in the cloud providers, but they change the way they do things and they come out with better recommendations. They come out with more specific guidelines. They come up with better tools. It is now very clear that you can take your S3 bucket and enforce blocking on that S3 bucket from public access, right? So a few years ago, that wasn't that clear, and people were just throwing S3 buckets all over the place. Now I think you have to like click yes like 3 times before something can get on the internet. So the cloud provider makes changes, and so the security finding program, even if you were 100% locked down, you're constantly trying to rebuild and add to it and make changes. So one of the big things that we had to do is make sure every resource has an owner. And if we don't know who the owner is, then we define somebody as default owner, which people don't like to be default owner of stuff, but if you don't tag things. So you have to build out a tag policy of some kind. It has to be something that is 100% enforced, and that is very, very difficult. So if I were to say, I want to be able to tag all of my resources in my AWS accounts, and I've got 10 accounts, that's a lot of work to go and tag them, right? But if I were to go and tag my account itself and say everything in here is under a certain team, that's a lot easier to do. And so, but whatever the process is, and every place is different, you figure out what that looks like. For us in Azure, we ensure that we've enforced tagging at the subscription level, and then you can create different tags at resource and resource group level, and it's kind of a hierarchical, works very well. It's enforced. We always know who owns everything. AWS, we do it at the account level, which is a little bit wonkier, but that's there is no resource group designations in Azure. Well, there is in AWS, but nobody ever uses them. So it's a little bit harder. But so we need to make sure we have their owners. We needed tools to be able to do the tracking and also notification of owners. Hey, you need to go and fix something, which we already had built in for another process. So we just leveraged that. And then the last thing we really needed was leadership has to be an advocate, not a supporter. And what I mean is, if I have an idea and I go to the boss and they're like, that's a great idea, that's a supporter, but it's not really going to get done. But if I go to the boss and I say, hey, I have an idea, and they're like, that's awesome, what can I do to help you? That's an advocate. If you're going to make changes in your security environment and you as a security team are going to be telling a bunch of engineers they have to go make changes, leadership has to be an advocate. They have to drive resources. They have to change priorities. So you need that kind of thing. Because we are competing with our engineers to do things that they're required to do for deploying the next capability or improving resilience or whatever it is they're doing. Security is now adding something else to it. So we are in competition with energy, basically, is how I look at it. And so we try to do, from that top level, really good documentation, really good auditing, alerting, and making sure that it's implemented really well so that it's less energy for the engineers at the bottom. So that's our alert-based program. So it works really well. However, that problem at the bottom is difficult because we're always going to tell people, hey, you deployed that wrong after the fact, right? So we don't really want to do that. We want to back it up a little bit. And so what we start doing is looking at what we call guardrails. And our guardrails are designed to say you can't deploy unless you meet a certain set of requirements for your resource. And you want to make sure that whoever's deploying, if they get denied, there's really good feedback. They understand why, they got a place to go look, and they can go and figure out, oh, this is why I can't deploy it. So we leverage our security findings program to specify, hey, this is the security requirement. Storage accounts in Azure, I don't know if you know this, you probably do, you all know this, but storage accounts in Azure, they have these really, these 2 keys that are generated when you create the storage account. And if there's used to be called shared access keys, but if you share them, whoever holds it has full read, write, and delete of everything in the storage account. It's like a terrible idea. It's just really bad. So you want to stop that, but it's on by default, right? And so you can create a policy or a guardrail that specifies you can't deploy allowing use of those keys. So that's kind of where you want to start blocking. Both AWS and Azure approach guardrails very, very differently. And so we start looking at our AWS ones. In AWS, we have 2 different kinds: service control policies and declarative policies. So service control policies are the ones that have been out the longest. They actually just got a real good update so that they can be even more performant and capable. But they're designed to control actions in the AWS environment. So an action would be run a virtual machine. If I'm going to run a virtual machine, you must have these kind of things in place in order to run the virtual machine. So what it's doing is it's monitoring the run instances service. That's what it's looking for. So looking at run instances, Identifies, are you meeting the requirements? And if you are not meeting the requirements, then it blocks you. You can put your service control policies on at account levels, and you can apply them at organizational units as well. So it's really good. So AWS, I've got, I don't know, 100 accounts. And I'm not saying I do, I'm just making this example. But you got 100 accounts and you split them up in the different organizational units. You can create a policy that says, in order for you to create a virtual machine, you have to have an owner tag assigned to it, right? And so we apply that service control policy. We can do it on each individual account, or I could just do it at the top level and require it for everybody. And now when someone tries to create a virtual machine that does not have the owner account, they get an error message. The problem is the error message does not tell them what they did wrong. In service control policy, right now, the error message says you don't have permissions to do that, which is not true. You do have permissions to do it. You just have to have this tag for virtual machines. What's the biggest problem I have with the service control policy? That is absolutely the biggest one. So as we start putting out service control policies, developers start doing things and hitting against these policies, they get error messages that don't tell them how to go and fix the problem. So when I look at my security findings program, we have to have documentation and implementation as two of our requirements. I can't communicate that through service control policies to the end user. And it's a problem. It's a problem I don't know how to fix, to be honest with you, other than people, Googling or something inside of our environment. There's also declarative policy. So declarative policy is really kind of what we want. Declarative policy is, hey, listen, if you're going to have a resource, it has to meet these requirements, right? So instead of it being an action-focused blocker, it is actually a blocker of the resource and how it's deployed. That's great. It's actually easier to understand what your intentions are. The service control policy looks kind of weird when you write it. If you're saying, oh, virtual machines must require to have this tag, writing the policy is just kind of wonky. It does allow for you to have custom error messages so that the receiver sees, oh, I did not add the tag. Love that. Problem is, it supports almost no resource. So that's a problem. So declarative policies, I am so hopeful that they'll start spinning out more and more capabilities to look at more things, public images, things that are publicly available. Those are usually what declarative policies are focused on right now, but hopefully that is where we're going. Is anybody using declarative policies in your environments? One? Anybody over here? I look at me, I'm like, I should have bought a visor. Anybody else just one? Wow, yeah. Is it because it's limited? Yeah, it's because it's limited. I know when I saw it, I was like so excited. And then I was reading, I was like, oh, I can barely use this. So yeah, so I have hope for the future that that's where they're going to go. So in a service control policy, looks like this. We write it in JSON. And it's just the name. You can be whatever you want. I copied this off the internet, so let's just copy that name. The effect, the thing I want to do is either allow or deny. Okay. The action that I'm triggering off of is run instances, which is create virtual machine. So why don't they just call it create virtual machine? I don't know. But anyways, if you ever take my class, basically I complain about the naming structure sometimes because it confuses me. AWS has Neptune. I don't know what that is. All right. Anyways, so I have a run instance. So that's the thing that we're going to be monitoring or looking at. And so we're going to also identify a resource or a set of resources. Right now, we're just saying all instances and all accounts across all regions have to meet this requirement. And the condition is the EC2 instance type is not T2 micro. Okay, so you can't run any T2 micros. And so that's the requirement for this environment. Okay, so that's how the service control policy is written. It can be a little bit wonky to read, and it can be problematic if you've got lots and lots and lots of, and you're starting to be very specific, like for that resource, if it's like instances, but the ones that start with certain parameters or values and other stuff, it can get really complex in that. So we just got to be careful. But that is our guardrail that we have for AWS. Another problem with AWS is that if you have an environment where you've got multiple accounts, all part of an organization, there is a top level account that's like the organization boss. You can't apply policies there because, quite honestly, if you mess something up, then you really lost control of your entire organization. Unfortunately, I talked to a lot of people that they're running production in that organizational account, so you can't put service control policies there, which can be difficult. For the most part, things like tags and the way we've implemented stuff, all the actions here, you can look at the full gamut of actions that are available in AWS. I think that was the latest one, is you get basically the full identity access management language to play with, where before it was limited. But there's a lot of great things you can do with service control policy. They become really important. So that's AWS. In Azure, I like Azure better. And I'm not saying this because I work for GitHub, but I just find that it has more capability for me. One of the things I really like about Azure policies is that my policy, which is a guardrail, our policy allows me not only to deny something, but audit. So when I was talking before that in our service management, when we figure out security findings, one of the first things I have to do is make sure, can I audit it? Well, I can audit with my Azure policy, which is great. So I just specify it, say, hey, you're going to audit. It just tells me how many things match it or don't match it, and that works really great. You can apply this policy at the organizational level, management groups, subscriptions, resources as well, which, most people, I recommend doing at the subscription level. It's just easier to manage. And you can put it in multiple different places. And what's happening here is Microsoft is leveraging the fact that in a Microsoft organization of a tenant with OUs and subscriptions, the dividing line between subscriptions is a lot softer than AWS. Like AWS, it's an account. You authenticate with the account. You're working in the account, right? I mean, that's how they've kind of built it. Whereas in Azure, you're like, oh, there's 20 subscriptions. And when you authenticate into the tenant, you could be given access to all the subscriptions. So it's a little bit squishier, which allows you to kind of do this more complex application denies and allows. Also supports exceptions. And so you could create an object that says, oh, I'm going to accept this, this one resource because whatever reason they can't implement the guardrail. So you can apply that. The other thing I really, really like about it too is that not only can I audit and deny, but I can also fix. So a really easy one is logging. So we should have logging turned on all the subscriptions for activity logs, right? Right? Yes. Okay. Yes, you should. And they should all go to your SIM, whatever that might be. In order to do that, let's not rely on human beings to go and turn on the logging. You can create a policy that's basically states, and I'm using kind of pseudo code here, but its policy basically sets, turn on logging for every one of your subscriptions, send the logs to this location. And then if someone has a subscription without logging, go and turn it back on. And that ability to make changes in the environment, all within the same policy, lets it become really, really powerful. So logging is a great one to do it. If suddenly there's a requirement that you need to block some capability across your entire environment, you can do it all with policies. It gets a little dangerous though, because as a security team, you probably don't know every team that's running, depending on the size of your company, but you just don't know what everyone's doing. There might be a reason, and there might be something they have to fix, and I can't really implement that policy right away. And so just applying like an automated deny or fix across the board can be a little bit dangerous. So we'll have to kind of figure out some strategies for that. In my Azure policy, there is a type, and this type is going to be virtual machines. I'm going to specify my field that I'm going to be looking at, which is the Microsoft.compute virtual machines, the SKU names or the type, the machine type, and it has to be one of the G series. Right? If it is one of the G series, I want you to deny something happening. Now, what am I denying? I don't have a specific action like I did in the other one. There's no run instances or run virtual machines. So what it is any edit that you want to make to this or create that you want to make to a particular virtual machine, it must meet this requirement. This basically blocks anybody from deploying a new system that's using the G series. All right. There are ways to specify that apply this only to creating a policy, which is kind of nice. Or I'm sorry, not creating policy, creating a resource. So you could say only apply this for new creations, but don't let somebody not be able to edit their VMs if it's part of the standard G, which is a really nice little added feature that you can add to it. But for the most part, what we're doing, we're saying this is the requirement we want to implement. And because I'm doing this in the policy, I specify what I want the resource to actually look like. So I can have multiple one of these things. I deploy the policy, I specify where in my organizational group that I want to apply this, and then I can sit back and look at my audit as it comes back. The service, the management on the Azure side, like the whole compliance thing, is actually really complicated of the kind of the data behind the scenes. We've done a lot of code to try and extract my compliance level to see where I could be applying a deny. And it was really difficult. Like, it's just like a really kind of crazy data format behind it. The GUI you can look at, but in Azure, man, the GUIs, if I have a GUI with a filter and I copy and paste it and then put it into my book, somebody else clicks it, they get a completely different view. Like, it's just really possible. So we use a lot of code to try and extract, like, this is where we're at and this is where we want to go. And it's very, very, very complex because of all the different features in Azure. And that's kind of a typical thing. Like, the more complex it is, the more features it has, the more complex it is. And so that we kind of see that. So I want to kind of spend some time, now we kind of talked about like the basic building blocks. I wanted to speak on like kind of the approach that we have for the program. So, and this is kind of generic. I'm taking what we've learned in our current environment, kind of made it a little more generic for you. But first thing we had to do is figure out, all right, if I'm going to implement policies, I can't implement the same deny policy to every single place, because you have production teams that operate a certain way. And then you have teams that are doing research and they need a little more flexibility. You've got your dev teams and you got, I don't know, your customer engagement teams. They're all going to be a little bit different, have different requirements. And some of them are working with customer data. So you definitely need to lock that down. Others are not. So maybe you don't have to worry about it as much, because as a security team, we're not really protecting servers, we're protecting data. That's usually what our main focus is. So what we got to figure out is, all right, how are we going to kind of separate this so I can apply policies at different levels? And so what we did, we reorganized all of our organizational units so that accounts or subscriptions, both AWS and Azure, they're grouped under like environments. So production systems are in one place, research teams are another, people that are engaging with customers are in a different place, and we kind of separate them. So once we kind of separated them out, we basically took all of our security findings that we had that were alert-based, and we deployed them all as policies for Azure, speaking specifically for Azure right here. So we deployed all those so that the policy itself was prepped and ready. It was at audit. It was a copy of what we were already doing. We have another third-party system that was doing the investigation and compliance evaluation. And we deployed our policies so that we could get kind of information about where we're currently standing. So once we have our audit policies across the board, it's time to start actually locking things down. And I'm a really big proponent of doing easy stuff first. Important stuff like criticals, we'll put that aside, because if it's a critical problem, you work really hard to implement those first. But once you start looking at the things you're going to figure out next, I always look at something easy. And so we start looking at things that are already 100% compliant and switching those to deny, which seems like it won't make an effect, right? But you start finding problems maybe with your policy. Azure has a lot of built-in policies that you can go grab, but they usually don't hit the mark exactly for what you want. You're going to have to customize a bunch of them. And so being able to quietly and quickly turn these on that should have little to no effect, and then figuring out where we gone wrong, what are our gaps. By doing this, we learned a lot about how to go and get information about what 100% means and what that data looks like behind it. It turns out you can very easily query Microsoft and say, tell me about the policies that are 100%, but it won't come back with policies with 0 resources. It actually doesn't come back at all for that. They were like, okay, now I got to make another query. So things you learn as you kind of get under the hood. We start deploying our denies into resources for small batches, like really small, very specific, over communicate with the teams, making sure they understand what's going on. A lot of times we have teams that come and say, hey, listen, we keep deploying this thing. We get a security fine. We have to go fix it. Can you just block it for us? And boom, we can turn it on. We can block it. Even stuff that's operational. I don't have to just be security. And I think that's a big win with teams. I talked earlier that there are these energies that we're kind of going against with our security teams. Like, they have a problem they have to fix. If I, as a security person, can find a way of supporting their operational requirements, they're more likely to let me do something on the security side. I've done that in my company, and it's worked out really well. In this particular case, I can go to them and say, listen, do you have a requirement for how you deploy stuff? Maybe it's an operational thing. I can fix that with this policy. Not really a security thing, but we can do that specifically for you. Then the last thing we do, And also the first thing is measure everything that we do, everything we deploy. How long does it take to deploy? What are the information that comes back? Do people make comments on it? Do we find that we deployed something and did not get an expected result? Our policies, and we also have a third-party service that does audit. So we have two different systems. And it's funny because if I think I'm putting out the same policy, the numbers come back different. And I realize, oh, I got to tweak. I got to do something. So always measure. We always figure out what we did wrong. And then we go and grab the next batch of systems and say, all right, now how, or accounts, how can we lock these down? How can, and you keep pushing that flywheel over and over again. And then eventually you're going to start locking down large parts of your organization. And in that case, you're not spending all your time fighting with people to say, hey, listen, we go make changes and go and change it in 3 months and they have to add it to their dev cycle. We try and do it right here in the beginning. We're in the middle of this process of locking things down. Our next thing is to figure out how to let the developers know ahead of time that they're about to deploy something that's going to break their security requirements. And that is great if we can figure out teams that are using something like Terraform, because we can easily build tools for Terraform to do this kind of deployments. And we can provide that information further and further back in their deployment lifecycle. That's the goal. Maybe that'll be next.